At this point, I've shown you guys how to graph or how to find the vertical asymptotes, how to find the horizontal asymptotes. We're going to put it all together and actually graph our rationals here. But before we do that, just some quick reminders. Vertical asymptote, there's a couple of different ways that we can find it. What's one way we can find the vertical asymptote? Set the denominator equal to 0 and solve it. That's one way. Where else can we look for vertical asymptote? Graph and table. And what are we looking for in the table? Error. You can find the error, you can find your vertical asymptote. Horizontal asymptote. What about the horizontal asymptote? What are we looking for to find the horizontal asymptote? The degree of the numerator and the degree of the denominator. Let's see how many of you remember this. If the degrees are the same, they're exactly the same in the numerator and denominator, what do we do to find our horizontal asymptote? Divide the leading coefficient. Okay, divide the leading coefficient. What if the degree is higher in the numerator than it is in the denominator? What kind of horizontal asymptote do we have there? None. And if the degree is higher in the denominator, then we have y equals 0. Okay, so those are the horizontal asymptotes. So like I said, today we're going to be putting it all together and getting the graphs of these rational. All right, so here we go. As you can see up at the top, it says the first thing we're going to do is locate the vertical asymptotes. And you guys just told me how we can find that vertical asymptote. And that's to set the denominator equal to 0 and solve. Set the denominator equal to 0 and solve. So that's going to give us our vertical asymptote. Number 2, find the horizontal asymptote. Again, you guys just told me how we could find the horizontal asymptote. And that's by comparing your degrees in the numerator and in the denominator. And depending on what we end up with, we'll determine what kind of horizontal asymptote we get. Of course, once you find those vertical and horizontal asymptotes, you'll go ahead and draw those with dotted lines. Once you know where those vertical and horizontal asymptotes are, you draw. Then you can go ahead and make yourself a table of some important values and then plot those points on your graph. So that's what we're going to be working on today. Drawing our asymptotes, getting some points, and then go ahead and creating our graphs. So they got to start us off with an example here. As you can see, the first thing they did was get the vertical asymptote by taking the denominator, setting it equal to 0, and solving, which in this case is x equals to -3. Then they found the horizontal asymptotes by looking at the degree of the numerator and the denominator. And since they were the same, they took the leading coefficients and divided them. So 2 divided by 1 ends up giving us a 2. They drew both of these lines. Here's the horizontal asymptote. Here's the vertical asymptote. Then they went ahead and created a table of values to plot points and get our graph. So that's what we're going to be doing here today. All right, so let's try one. First one, x minus 1 over x plus 2. First, we're going to find the vertical asymptote. So we're going to take x plus 2, the denominator, set it equal to 0, and solve it. Well, that's pretty easy. Subtract 2, and we get a -2. So x equals -2 is our vertical asymptote. So I'm going to go ahead and draw it right now. X equals -2 is this vertical line going to -2. Make sure you draw it with a dotted line. Now we're going to find the horizontal asymptote. And to find the horizontal asymptote, we've got to compare the degrees. So the numerator, what's the degree of the numerator? 1. Remember, degree is the highest exponent, largest exponent. What's the degree of the denominator? 1. Notice how the degrees are exactly the same. And because they're the same, we need to take the leading coefficients and divide. So our leading coefficients are 1 and 1. So 1 divided by 1 is 1. So our horizontal asymptote is at 1. All right, so there it is. So I know where my vertical asymptote is. I know where my horizontal asymptote is. Now I need to get some points. So now we're going to go to our calculator. We're going to go to y equals, and we're going to type in that function, x minus 1 over x plus 2, so that we can get a table of values. So let me let you go ahead and get that in there. Now notice they didn't give you any specific x value, so you can use any x values you want, but I recommend that you make sure you choose x values that actually fit on our graph paper here. So notice if I choose -10 as an x, well, that's not going to do me any good because that's not going to fit on my graph paper. So just make sure you're choosing points that actually fit on the graph that we're given. Okay. Now here's a couple that I use. I use -5, -4, -3, -2, -1, 0, and 1. Do you have to use the same exact ones? No, you don't have to use the same ones as I do. Just make sure yours fit on the graph paper. All right, so next to -5, I saw a 2. Next to -4 was a 2.5. Next to -3 was 4. Then I had an error, -2, -1/2, and 0. Your table may look a little different from mine. That's okay. In the end, we should get the same graph. Anyway, I'm going to start plotting some points here. The first point I'm going to plot is right here, -5, +2. So I'm going to find -5, +2, which is right here. Then I'm looking for -4, +2.5. It's a little higher. -3, +4. Notice -2 error because that's where my vertical asymptote is. So I've actually got part of my graph right here. Now remember, when you draw this, we are getting close to those asymptotes, but if we don't actually touch them. So when you connect the dots, be careful not to touch the asymptote. All right, let me keep going here. -1, -2 is the next ordered pair. That's right here. Then I had 0, -0.5, and then 1, 0. Now, of course, the more ordered pairs or more coordinates I get, the more accurate my graph is. But this is the idea here. Plot those points, get the graph. Of course, we can always confirm this graph to make sure we're right by looking at the graph on our calculator. The graph on our calculator should look pretty much like what I have here on my paper. All right, so that takes care of number 1. Graphing the vertical asymptotes, horizontal asymptotes, getting some points, and then plotting those points. All right, let's keep going here. Number 2. Again, the first thing we're going to start with is finding the vertical asymptote. So I'm going to take my denominator. I'm going to set it equal to 0, and I'm going to solve it. So if I solve that, all I got to do is add 3. So 0 plus 3 is 3. So 3 is my vertical asymptote. So I'll come over here and draw that right now. There's the vertical asymptote. Now I've got to find the horizontal asymptote. So to find the horizontal asymptotes, I've got to compare the degree. So the question is, what's the degree of the numerator asymptote? 0. Jose, what's the degree of the denominator? 1. Notice how the larger degree is at the bottom. So what are we going to have for our horizontal asymptote? 0. Y equals 0. Y equals 0. So you're going to come over here and draw your horizontal asymptote through 0. So these are the two lines that we're going to get close to, but we're not going to touch them. Now let's fill out the table. So you're going to go to your calculator. You're going to type in the function -4 divided by x minus 3. Get yourself the table of values. Just make sure these ordered pairs that you're choosing actually fit on the graph paper. If I use a value for x such as -10, notice -10 won't fit on my graph paper, so that's not going to do a whole lot of good. We're trying to get values that actually fit on your graph paper. All right, so here's a couple of values that I chose for x, 0, 1, 2, 3, 4, 5, 6. You don't have to use exactly the same ones. These are just the ones that I chose. All right, so let's see, next to 0, was 1.3. Next to 1 was 2. Next to 2 was 4. Next to 3 was there, which should be there because that's where our vertical asymptote is. -4, -2, and -1.3. Again, your table does not have to look exactly like mine, because in the end, we should end up with the same graph anyway. So I'm going to go ahead and plot my points. You do the same thing with yours. 0 and 1.3. I'm going to find 0, 1.3, which is somewhere about right there. 1, 2, 2, 4, 3 error. I can't graph that or plot that, so I'm going to go ahead and draw half of the graph. Notice I get close to the asymptote, but I don't touch it. 4, -4. Then I had 5, -2. And then I had 6 and 1, -1.3. So my graph looks something like this. Yours should do the same thing. Even if you chose different points, different order pairs, we should all have the same graph. So that's number 2. Let's go on to number 3. A little bit different here on number 3. Number 3, vertical asymptotes. First, I'm going to go ahead and take my denominator, set it equal to 0, and solve it. First thing I notice here is that I'm working with a quadratic. So if I solve this quadratic, how many solutions should I have to a quadratic? 2. So the question is, how am I going to find these 2 solutions? Yeah, you got 3 methods. Graphic, factory, quadratic one. You choose which one you like best. All I need is, what are those 2 vertical asymptotes? Again, if it was me doing this, I'd probably choose the graphing because it's just faster and easier. Graph it, find the x-intercepts, man, you're done. All right, Marty, did you find them? Oh, where are they? 3 and -3. 3 and -3. So 3 and -3 are my vertical asymptotes, correct? Correct? What did we say yesterday? Are they necessarily going to be the vertical asymptotes? What did we find out yesterday? One of them might end up being a removable discontinuity. And how do we know if we have a removable discontinuity? Okay? If I plug in 3 on the top and on the bottom, and I get a 0 on top and the bottom, we've got a removable discontinuity. But is that going to happen in this case? No. So yes, you are right. Both of them are vertical asymptotes, but we got to be careful. Be very careful. All right, so let's go ahead and draw those. 3. That's one of my vertical asymptotes. But I got a second one, -3. So draw that one for me as well. 2 vertical asymptotes. Horizontal asymptotes. Let's go ahead and compare the degrees. The degree for the numerator is a 1. The degree for the denominator is a 2. So notice how the larger degree is down at the bottom. And when the larger degree is down at the bottom, what kind of horizontal asymptote do we have? What's that? Y equals to a 0. So our horizontal asymptote is going to be this x-axis. So those are the vertical and horizontal asymptotes. Now I got to come over here and create a table of values. Let me go ahead and give you a chance to do that. Get a table of values. As a matter of fact, I'll be calling someone up here to give me their table of values so we can use it to correct. And this graph will look a little different from some of the others that we had, guys, because we have 2 vertical asymptotes. So don't freak out on your graph. Notice some of you on your table, your y values, you have them written as fractions, which is fine. But you may need to convert those fractions to decimals when it comes to actually plotting those points. For some of you, it may be a lot easier to find something like a 0.5 than it is to find a 1/2. So if you need to convert your decimals to fractions, or your fractions to decimals, do that so that it's a little bit easier to plot your points. Just remember, guys, when it's all said and done, you should not be touching your vertical asymptote or your horizontal asymptote. It's going to look a little different. There you go. Now, this one right here. All right, so here we go. Here's a table of values. Remember, you may not necessarily have exactly the same table of values. That's okay. We should all end up with the same graph in the end anyway. All right, so this is Garrett's table of values. Go ahead and plot those for me so we can see what your graph ended up looking like. All right, so these are the plots he's plotted. Go ahead and connect those dots. What is it going to look like? There you go. So again, notice how it approaches the vertical asymptote but doesn't touch. However, that's not the only part of the graph, right? There are a couple of other pieces. So what do the other pieces look like? Just go ahead and sketch them for me. All right, so there's the other parts, and there's the third part. Now notice these last two pieces here, he just kind of sketched them out. Had we chosen some x values such as -4, -5, -6, it would have maybe given us a little better picture of what this piece would look like. Same thing over here. Had I chose values such as 4, 5, and 6, I could be a little more accurate over there as well. Right? But this is the general idea. This is what the graph should look like for number 3. Matter of fact, if you put that in your calculator, that's what the graph you're going to see. Again, it looks different because we have two vertical asymptotes. I got one last one to look at here. Number 4, vertical asymptote. Let's find that first. Let's take our denominator, set it equal to 0, and start solving it. First thing I'm going to do is subtract the 5. Then I'll go ahead and divide by 2. So the question is, what's a -5 divided by 2? -5 divided by 2. -2.5. So when you draw your vertical asymptote, you're going to draw it over here at -2.5. There's the vertical asymptote. Now we're going to find the horizontal asymptote. So we're going to compare the degrees. Notice the degree for your numerator is a 1. The degree for your denominator is a 1. And because they're exactly the same, rule says I need to divide the leading coefficient. So I need to divide -2 by a +2. And a -2 divided by a +2 would end up being a -1. So your horizontal asymptote is over here at -1. Now you're ready to start getting some table of values. So go ahead and put that in your calculator. And let's get a table of values. Again, your calculator may be giving you your y values as fractions, which is okay, but it makes it a little easier if you convert those fractions to decimals. It's a little easier to find. All right, so here's the table that I came up with. I went ahead and used the x values -4, -3.5, -3, -2.5, -2, and -1.5. You don't have to use necessarily those same exact x values. So the y values ended up being -2.6, -3.5, -6, error, 4, and 1.5. So those are the points that I'm going to plot. So -4 right over here, -2.6 would be somewhere about here. -3.5 and -3.5 right about there. -2.5 error, well, that's where our vertical asymptote is. So my graph looks a little something like that. -2, +4 would be up here. -1.5 and +1.5. So my other part of the graph is going to look something like this here. Again, you don't have to have necessarily that same exact table, but the graph should look pretty much the same as what I have. All right, so pretty easy. All we're doing is finding the vertical asymptotes, horizontal asymptotes, creating a table, and then plotting those points off of that table. No big deal. All right, so that takes care of the notes.